Okay, the last thing that I noticed on the curriculum and a few problems on your review is arc length. So I want to talk about a little bit what it is and where it comes from, and we'll talk more about it this week. So arc length is just the distance along a curve. So just like with a circle, you have circumference, and if you have a rubber band or something and you snip the circle and you pull it tight, it's a linear measure. Well, here it's not linear. So if I put a piece of yarn or something over this curve, I would want to know what that length is. And again, if I picked it up and pulled it taut, then I could measure it with a ruler and get a number. All right, so the formula for arc length, there's actually two, but it looks like there's nothing in your curriculum as far as work is concerned on it. However, when I saw them in the exam review, I thought, well, I better at least teach this one. The arc length is denoted S, and it's the integral from a to b of the square root of 1 plus the derivative of the function squared dx. All right, and all it is a Riemann sum. If you think of this curve between a and b, we always start with an x naught and end with an x sub n for a and b respectively. And if we cut this thing up perpendicular to the x-axis, we can call this x sub 1, x sub 2, blah 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 in between. Okay, and for each one of these things corresponds a point on this curve. And the idea is that we can connect any 2 points and find the slope of a little secant line there, right? But this distance here is the change in x. So just take one partition here, or one subinterval between x sub 1 and x sub 2. This distance is the change in x, and this is the change of y. And this here would be, we call it ds, all right? So in differential notation. And by Pythagorean theorem, we know that the hypotenuse squared is equal to leg squared plus leg squared. So if I take the square root of this mess, I get ds is equal to the square root of dx squared plus dy squared, just the distance formula, right? Because you know how to find the distance of a linear function. You use the distance formula, distance between 2 points. So it's similar. And then factoring out a dx squared, right? If I factor out dx squared, it means I'm dividing each one of these by dx squared. Then I'm left with 1 plus dy over dx squared. dy squared over dx squared is the same as dy dx quantity squared. And remember rules of radicals, right? If I can write the radicants as a product, then I can rewrite them or think of them, under their own little radicals here, under their own houses. dy dx quantity squared. So the square root of dx squared is just dx, and then the rest stays under the radical. Well, dy dx is f prime of x, so this is the formula that's easiest to remember. Now, these are not bad. However, sometimes the algebra involved can get a little bit tricky. And what I'm thinking is I don't see a non-calculator part of your exam, so I don't know if you're going to get to use the calculator for the whole test or not, to be honest. Based on this information, what you're going to do essentially is you're going to be given a function. So I'll just use like the first one. This is number 53 in your packet. F of x is 2 times x minus 1 to the 3/2, and the interval is from 1 to 5. We want to find the arc length of this thing. So the first thing I would do is take the derivative. So bringing this down with chain rule, that's going to give me a 3 times x minus 1 to the positive 1/2, and the derivative of the inside is 1. So this is my derivative, and if I square that derivative, then that's going to give me 9 times x minus 1, and I could write it like this if I wanted to. So filling in the formula, I would say the arc length is the integral from 1 to 5 of the square root of 1 plus 9x minus 9. And I can clean that up a little bit, of 9x minus 8, right? Now, the thing is that, you could use a u substitution here. That wouldn't be that bad. But again, I'm thinking that they want you to use your calculator for these. So you could go ahead and pop this into your calculator just as you see it. So I'm gonna, I don't know if you'll be able to see here. You do math 9, which is that FNINT, from 1 to 5 of the square root of 9x minus 8. And of course, integrating with respect to x, and hit enter. And the length of the arc should be about 16.6. All right, so we'll work on doing some by hand, because just in case, because I don't know. In fact, in the curriculum it's there, but they don't make any mention of any homework assignments for it, nothing. So not sure where they're going with it. I mean, I know what they're doing with it, but as far as what you guys need to know, I don't know if it's all on the calculator, or if you do need to know how to do it by hand. It wouldn't hurt to know how to do it by hand, but anyhow, we'll talk about it next week. You have been exposed. See you later.